Hi everyone, this is Saranya. In this video, we'll be talking about multiplexer and demultiplexer. The aim is to design and implement multiplexer and demultiplexer using logic gates. The procedure is being given below. We have to give connection as per the circuit diagram. Logical inputs are given with the help of the truth table and we have to observe the output and verify the truth table. Let's move on to multiplexer. Multiplexer means transmitting a large number of information units over a small number of channels or lines. A digital multiplexer is a combinational circuit that selects binary information from one or many input line and direct it into a single output line. The selection of a particular input line is controlled by a set of selection lines. There are two per n input lines and n selection lines. So this is the block diagram of 4 into 1 multiplexer. There are 4 inputs D0, D1 and D2, D3 and 2 selection lines S1 and S0 and 1 output that is Y. So the function table has been given below. With the help of the function table, we'll be getting the characteristic equation of the multiplexer. This is the circuit diagram. S1 and S0 are connected with 2 NOT gates and there are 4 input datas and 4 AND gates, 3 OR gates and the Y is the output. So this is the truth table. S1 and S0 are the in selection lines and the output will be Y. Let's move on to the working of multiplexer. So as I said, S1 and S0 are the selection lines which are connected with the NOT gate and these are the 4 input datas D0, D1, D2 and D3. We'll be requiring 4 AND gates and 3 OR gates and 1 light bulb to show the output. So we'll be requiring 3-pin NAND gate. So let's give the connections. As I said, we require 3-pin NAND gate. It's shown here, 3-pin NAND gate. When both are 1, that is S1 is 1 and S0, when both are 0, S1 is 0 and S0 is 0 and D0 is 1, the output will be 1. The output will always be 1, but we have to know which input data gives us the output as 1. So when both are 0, D0 is 1, the output will be 1. When S0 is 0, S0 is 1 and S1 is 0 and D1 is 1, the output will be 1. When S1 is 1 and S0 is 0, D2 will be 1, the output will be 1. When both are 1, D3 connections will be in blue color, that is it is active, and so that is D3 is 1, so output will be 1. This is the working of multiplexer. Let's move on to demultiplexer. The function of demultiplexer is in contrast of the multiplexer function. It takes information from one line and distributes it to given number of output lines. For this reason, demultiplexer is also known as a data distributor. Decoder can also be used as a demultiplexer. In 1:4 demultiplexer circuit, data input line goes to all of the AND gates. So this is the block diagram of 1:4 multiplexer. There will be one input line. But in multiplexer, we saw there are 4 input lines. So the output lines here are D0, D1, D2 and D3. There are 2 selection lines S1 and S0. So this is a function table of demultiplexer. With the help of the function table, we will be getting the characteristic equation which is represented here. This is the circuit diagram. S1 and S0 are the selection lines which is connected with the 2 NOT gates and 1 input data and 4 AND gates. The truth table is being given here. So the components used here are AND gate, NOT gate, which AND gate IC number is 7411, NOT gate IC number is 7404. So let's move on to the working of demultiplexer. As I said, we require 2 toggle switches for selection lines. This is S1 and S0 and 2 NOT gate which are connected with the selection lines. This is the input data and these are the 4 AND gates. So we'll just label them. This is S1 and this is S2. This is not S2. This is S0. This is input and these 4 are the outputs lights to show the outputs D0, D1, D2 and D3. So we are connecting this input to this 3-pin AND gate. We'll be requiring 3-pin AND gate here. We will be just giving the connections here. we will connect all the outputs of the AND gate to the bulbs. So when both are 0 and the input is 1, D naught will be 1. That is, when S naught is 0 and S1 is 0 and input is 1, the output will be 1. And when S1 is 1 and S naught is 0 and the input line is 1, D2 will be 1. When S naught is 1 and S1 is 0, input line is 1, D1 will be 1. When S naught and S1 both are 1, D3 will be 1 when the input line is 1. When the input line is 0, the output all will be 0. That is for all cases. So this is the working of demultiplexer, and thank you. Let's see in another video.